You've seen how easy resources make it to organize and reuse individual objects in your applications. Resources can contain different kinds of objects, but they're most often used for holding styles. A style is a collection of property values that you can apply to elements in markup. It's good for repetitive properties, margins, colors, gradients, padding, and fonts, and other things that you apply to multiple different elements and want them to look alike. Rather than littering your markup with property values all over the place, you can define a style that contains them all and apply that style instead. And the most likely place to store that style is a resource. That's why we have to cover resources first. XAML styles provide functionality much like you'd see with cascading style sheets for HTML, though they aren't the same, and the syntax is different, and really nothing's the same between the two, but the concept is the same. You need to be aware that Silverlight and WPF don't handle styles exactly the same. For example, Silverlight can't apply a style to all members of a particular type, attach event handlers using styles, attach a style to a container and have the style flow through to the children, or use one style with multiple different element types. WPF can do all those things. Silverlight cannot. What if you want all buttons in an application to share font information, the same background brush, and other layout characteristics? You could set up those properties for each individual button, but it sure would be easier to create a style and apply it to each button. Now think about what this means. This also means that if you want to modify the style, you only have to do it in one place. Styles apply only to dependency property objects. Other properties can't be included in the style, but luckily, almost every property you'll come across is a dependency property. Let's take a look at working with a simple style that we can apply to multiple buttons. I've loaded the user control simplestyle.xaml, and you can see immediately that there are 3 buttons on this design surface with very similar characteristics. If you examine the markup, you see there really isn't much here. But what you do see is a style attribute with a static resource as its value. The static resource is named colorful button style, and clearly that defines the style for each button. Each button has the same style attribute applied to it. Notice that the first button has its own margin settings while the others don't. We'll come back to that in a moment. Now, where would this static resource be? Well, it can either be on the button, well, it's not there, the stack panel, not there, the grid, not there. At that point, we look at the user control, and there we find usercontrol.resources containing a style element whose key is colorful button style. Its target type is a button, indicating that this style can be applied to a button. Inside the style element, we see setter elements. Each setter describes a property and its value. Font family and its value. Font size and its value. Margin, value, font weight, value, and so on, all with simple attribute values until we get to the foreground, where we have, perhaps unfortunately, a linear gradient brush describing that foreground color. Because linear gradient brush is too complicated to describe in a simple attribute value, we have to use the object.property syntax in an element to contain the description of the linear gradient brush we'd like to use. Now, the beauty of all this is if I want to change the color of that gradient, I can just come here, type a new color, and it changes the gradient for all of the buttons that use that same style. Or I can put it back. Also note that down here, these 2 buttons don't declare a margin, so they use the default style margin, which is 5 all the way around. This button has its own margin setting, and so it overrides the value in the style. We don't even use the value in the style. Instead, we use the single value listed here, which is 5, 20, 5, 5, and that describes the margin for this button. So as you can see, using a style can greatly enhance the ease of maintaining the look and feel of your application. the style element defines the style, and the style element included an x:"key" attribute which defined the key for that attribute. The style element includes a target name attribute which indicates which type of element this style is applied to. The style element contains setter elements, and each one of those includes property and value attributes. The style element can contain as many setter elements as necessary, and for complex properties, like that gradient, you need to use the child element syntax. To apply the style, you use the style attribute in the element to which you want to apply the style. There is one small difference to note. Silverlight requires the target type attribute, but WPF does not. If there's not a target type attribute, like button in our previous example, the property name must include class.property so the code can tell what it can apply to. The x:"key" isn't required either. Without the key, the style applies to all elements of the type in the target type attribute. So if you don't give a key, it will automatically apply the style to every element whose type is listed in the target type attribute. We'll look at that a little later on in this section. Why would you use styles? It allows you to create groups of related settings so you don't have to maintain them for each individual control. It streamlines your markup, making it easy to apply groups of settings. You have to agree, in the example you just saw, the markup for those buttons was awfully streamlined. There wasn't much there. You can apply a style without worrying which properties it sets. You can add a new property later or modify an existing one, and you only have to do it in the one place. There's no problem. The user interface simply updates with the new values you apply. Now I'm going to point out an important tool that Microsoft didn't create. Yes, other people do create tools. Carl Shiflett has a set of tools called the XAML Power Toys. This set of tools, which is very useful on its own, provides one tool which seriously applies to working with styles, and that is he provides a tool to convert properties of an existing element into a style. If you're going to be working with styles, this is a tool you have to have, because you can lay out one control visually to be exactly the way you want it, and then sort of extract the properties of that control, convert it into a style, and then apply it to lots of other controls. You would think something like that would just be built into Visual Studio, but it's not. In Visual Studio, there is a tool that can take a single property and convert it into a style, but that's not very useful. You'd have to do it for every individual property. This tool does it for all the properties of an element, and you can choose which properties you want to include in the style. So give it a look. Search the web for XAML Power Toys. You'll find this very important tool on the web. Now, normally, you apply styles in markup. You may have reason to be able to programmatically replace styles at runtime. It's pretty easy to do. All you have to do is set the style property of an element to a new style, and you can do that in code. Let's look at an example that shows how you can apply styles programmatically at runtime. I've loaded the sample user control dynamic styles, and it's not terribly impressive, but what you see is a grid containing a border, containing a stack panel, containing 4 buttons and a few miscellaneous controls. The point of this exercise is that by clicking each of those buttons, I can dynamically change the styles that are applied to these controls. There are also some default styles applied to the controls. If we examine this, you'll see that the border has a style named border style applied to it. The stack panel has no style, the buttons have no style, but the text block has a style named, let's see what it's named, text block style applied to it, and the radio button has a style named radio button style applied to it. So where do we find those styles? Not on the stack panel, not on the border, not on the grid, must be user control or higher. And here's the user control, and you can see the resources here applied to any control within the user control. And here there's a style named border style, whose target type is border, with properties set for border brush, border thickness, margin, and corner radius. Then a style named radio button style, which applies to a radio button, which sets the font and the margin. And a style named text block style, which applies to a text block, which sets the margin and the font family attributes of that element. Now at this point, if I run the application, you'll see that we can change the styles dynamically at runtime. So here's the application, and let me go to Dynamic Styles, click Silver Styles, and we switch to other styles. Not real attractive, but that's not my point here. Go to Black Styles, it looks a little different, and it looks a little different. Go to No Styles, removes all the style, and go to Default Styles, puts it back the way it was when we first loaded the application. Well, clearly there's some code running which attaches a style dynamically at runtime. Let's stop and look at how that code works. Here in the code for the user control, you can see there are 4 event handlers for the 4 buttons. Each one of them calls the set styles procedure, defined down here, and each one of them passes in either a path name to a resource file, the first 2 do that, a null value, or the string default, which will indicate to our code that we want to use the default styles for this user control. The set styles procedure, down here, accepts a file name with an optional parameter whose default value is default. We never use that option, but it's there just in case. And you'll see that we have 3 style variables, each one set to null. We also have a resource dictionary variable, again, set to null. If the file name is null as it comes in, that means we want to use a null reference for the styles and end up with no styles at all. We'll just not do anything right now. Otherwise, if the file name is default, we're going to store into that resource dictionary the current user controls set of resources. Remember, resources are just a dictionary of key and value pairs, so we're taking the resources from the current user control and applying them into that resource dictionary variable. If you passed in a path, that's what the else clause is here, then we'll create a new resource dictionary, take that file name, create a new URI, that is a Uniform Resource Indicator. It's a standard for indicating a resource of some sort. In this case, it is our file name. We indicate that the path is a relative path to the current path, and we store that into the source property of the resource dictionary. So now we have the resource dictionary pulling its contents from that file name that you specified. For each style, we'll use the key name to retrieve the style from the resource dictionary, cast it as a style, and store it into the individual variable. So each one of these variables refers to a single style. Now, if you passed in a null value, each of these variables will still be null. If you passed in a file name or default, those styles should be a real style. I didn't add error handling here, it probably could use it. In any case, the last step of this is to take those styles and apply them to the style property of each of the controls on the user control, thereby modifying the style of the control. So this procedure handles 3 different cases: passing in a null value, which means we get no styles, passing in the word default, meaning we get the styles that are already there within the user control, or passing in a path, which means we load the styles from the file that's specified by the path. Let's go look at those 2 sets of styles, silver and black, and see what they look like. It's important to note that if you want your resources to compile in as resource dictionaries, you must set the build action for each XAML file to page. You can see that here. I've set that to page. So make sure that you modify that build action, otherwise you won't be able to find the resources. Let me put these away so we can see what's going on. All right, so here we have our 2 resource files, both with their build action set to page. And you can see in here we have silver resources, we have black resources, and within here we have the various styles that we need. We have style, style, and style, and this actually uses a very interesting concept. We have resources used within the styles to keep things consistent. Here, for example, for the radio button style, we have the target type of radio button as it should be. We have the setter for foreground having a value which is itself a static resource. And the font color comes from, where's font color? There it is. So that's defined in just one place as well. So the point here is you can have styles that are resources whose properties are themselves other resources, making it even easier to conglomerate all of your settings in one place so you can have consistent styles. Multiple styles could use these same resources to define their behavior. If we look at the silver resources, we'll find the same sort of thing with slightly different values, but the same basic concept. Each one of these control styles uses setters that define values that are themselves static resources, which are defined right here. Using this technique, writing code to retrieve the style, using style sheets stored as resource dictionaries with the compile settings set to page, you can have as many different style settings as you want and let users switch between them at runtime. Imagine a set of styles that contains a set of properties, and you want to create a second style that uses those properties, perhaps plus a few more. You could copy and paste your styles using clipboard inheritance, but you can take advantage of XAML's ability to inherit styles. The based on attribute in a style does this job for you. It allows you to inherit a style, allowing you to add properties to the inherited style. So you can have inheritance trees of styles that inherit from other styles and build up styles in that way. Let's look at an example that uses style inheritance to create new styles based on existing styles. In this sample, Style Inheritance, you'll see a number of buttons on the page. Let's examine what the buttons have in them first of all. This button is a normal button with no style applied to it. This button is content of large button style, that's just the text you see, and it's got a style applied to it called large button style. The third button has a style applied to it, which is colorful button style. Let's examine those styles. Well, clearly they're not defined here. They must be defined at the user control level, and there they are. So there's a border style, which we're not talking about at this point, but we do have the large button style, which is target type button, which indicates a font family, a font size, a font weight, and a margin. The colorful button style also has a target type of button, but it's based on the large button style. And in this style, we can override settings and we can add extra settings. Here we'll set the foreground to red and the background to blue, and clearly that worked. We also got from the base style, large button style, the font family, font size, font weight, and margin settings. So we got all of those things by inheriting the style from large button style. Couldn't be much easier than that. You can override settings and you can inherit settings from the base style. You need to be careful about using style inheritance. You can create an entire chain of styles using that based on attribute. If you set a single property multiple times in the chain, the last instance wins, and that might be surprising. Properties set in the control take precedence over any style setting, so you can always override any styles by setting a property in the control itself. Using inheritance can make applications overly complex and brittle, so you really want to think twice about using this inheritance. Our example was trivial, but it gets complicated very quickly, and it's easy to lose your place and wonder, where did that style come from? Why is it doing this thing that it's doing? Because you can't tell where in the inheritance chain some property was set. In other words, don't inherit unless you have a good reason to do so. That is, you want to add a single property to some other style, or maybe you want to override some property in some other style. But otherwise, leave inheritance for another technique. But otherwise, I would suggest you don't use inheritance unless you have a good reason to do it. Every example you've seen so far includes a target type attribute, but WPF doesn't require that target type attribute. Without it, you will need to specify class.property. And in order for this to work, you have to understand the hierarchy of classes and how dependency objects work, and you must understand sharing of dependency property objects. If a style contains a property that doesn't apply to the current element, WPF simply disregards that property setting. There's nothing keeping you from having a setter element that specifies that the current setting applies only to, for example, button.foreground, and therefore it will apply to that particular class and property. And if a style contains such a setting that doesn't apply to the current element, WPF simply disregards it. Let's look at an example that uses this feature in WPF. In our example, typestyles.xaml, you can see within this grid a number of different control types. We have a button, we have a checkbox, we have a text block, and each one of them has the same style applied to it. This is the first time we've seen an example like this, where we have a single style applied to different controls of different types. Let's look at the styles and see how that can work. It's large control style we care about, and here in our usercontrol.resources is that large control style setting there. Now you can see that there is not a target type specified for the entire style. Here, however, we specify control.margin is 5, control.fontFamily, control.fontSize, and control.foreground. Well, clearly, something weird is going on. How can we apply settings assigned to control.margin, control.foreground to a button or other controls? Because they all inherit from control. So we've used the base class control here to indicate for any control that inherits from control, we want to set the margin, font family, font size, and foreground properties. And you're wondering, how come the button and the checkbox don't have a foreground of red? Well, because those have an isEnabled property set to false. Although this says button.isEnabled equals false, I'm guessing you figured out already that the button has its isEnabled property set to false, and the checkbox does too because, I'm waiting for it, because the checkbox inherits from button, and so it too has its isEnabled property set to false. We have border.background set to azure, and border.border thickness set to 5. Now clearly, those properties don't apply to many of the controls in the set that are using this style. For those controls, they simply disregard those settings. They have nothing to do with the button or the checkbox, so they don't apply and they are completely disregarded. You can see how powerful this is, but also how confusing it can be if you're not aware of the hierarchy of controls. You can automatically apply styles to particular types of controls in WPF. You simply supply the target name, but no key attribute. We've seen examples where you supply both. We've seen examples where you supply a key, but no target name. In this example, you'll see applying a target name, but no key. In that case, you create a style that looks something like this. It has a target type specified. It applies to any button. And you have a setter, or multiple setters, for the various property types you want to set. WPF creates the key, curly braces, x:type, button. Because every resource has to have a key, WPF creates this one under the covers. The x:type converts the type name to an actual type in memory, so they're keeping track of the type associated with this style. And it applies to every element of this particular type, which means you don't have to manually assign the style attribute for each button. If you use this syntax, this style will apply to each button in the scope of this style. Let's look at an example that proves this behavior. In this example, we have several buttons within a stack panel, and look at this button. Is that cool or what? Not a single attribute set. on this thing except the content, which it has to have to describe the text of the button. Here's a text box with text equals I'm using styles, but again, no other style settings. Here's a button with the content no style here with a specific explicit style set to the value x:null in curly braces. That value indicates that we don't want to apply the inherited style to this button. So you have a way to override the automatic styling of controls if you want to. Remember that. Curly brace x:null for the style indicates that there is no style applied to this control. But this is just amazingly sweet. Look at this, not a single attribute in here except for this one style, yet we do have styles applied to these controls. How did that happen? Let's come up here and look at the various styles, and you'll see that we have within our resources 3 styles. Each one of them doesn't have a key value defined here. WPF does under the covers, but we don't see the key. All we see is a target type, indicating that each of these styles applies to a different kind of control. We have one style for button, another style for border, and another style for text box. And clearly, they're all working. Our border has a thickness of 5, and it's got a margin of 0. Our button has the correct font weight, font family, margin, and font size. And our text box has the correct settings as well. So by just specifying the target type and not a key value, these styles apply to all the controls within this user control of the specified types. We don't have to explicitly apply the styles at all. And notice that this final button isn't using the styles because it overrides the style setting with its own style setting. Of course, it doesn't have to be a null setting. It could be any style you want. You can always explicitly override the styles. It's important to note that you can also override style settings by setting attributes here. We could, for instance, set font size equal to 10 in here, and that overrides the font size that's coming from the style. As you've seen, there's a lot of different ways to use styles. This is one of the coolest because it means that you can have very little markup describing your application and a consistent set of styles that apply to all the controls within the markup.